Hi, grade 11s. Today, we are going to take a look at what reciprocal functions look like, how to make them, and how to work with them. So let's think of the line y equals 2x plus 3. We see it pictured to the right. It has an x-intercept of -3/2, y-intercept of 3. What we want to do is we want to see what happens when we look at what the reciprocal of it is. The only coordinates that are affected by a reciprocal are the y coordinates. So whatever the value is, say if it's 4, well now if you're taking the reciprocal of 4, it's 1 over whatever that number is. So it's 1 over 4, or like a quarter, approximately 0.25. So under a reciprocal transformation, small y values become very large. Large y values become very small. Y values of 0 create asymptotes. And signs do not change. Okay? So going back up to here, I always start with where there is any x-intercepts, because that becomes your asymptote. I'm a little bit off here, but I'll move it to the right spot. There we go. There's our asymptote. And then now what we're going to do is we're going to graph it along here. Understand it says signs do not change. So since it says signs do not change, to the right of the asymptote, we're not going to be using anything down in the bottom right quadrant or bottom right part of the graph. Likewise, we're not going to be doing anything up in the top left part of the graph either. Okay? The signs on the y values do not change. So, let's see what we end up getting here then. Okay? Remember, small becomes big, big becomes small. So with that in mind, I want you to look at something with me here, okay? Well, I wasn't trying to zoom in that much. Let me try that again, maybe a little bit bigger here. Perfect. All right? So, when you look at values, that are just above the x-axis, you're like 0.1, 0.05, blah, blah, blah. When you go 1 over that, you get a big number. And as the line gets bigger, the original function, the reciprocal will get smaller. So if we're going to graph the reciprocal, it's going to start off really big. And 1 over what? 1 over what is 1? Well, the what is 1. So at 1, it's going to be 1. It's going to go like this. Then it's going to go down, 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 and go down like that. So that's what we're going to get. Likewise, it's going to be at -1. And really, really, really small negative is going to turn into a really, really big negative. Really, really big negative is going to turn into a really small negative. So we're going to get something that looks like this. I don't like how I graphed that, because the whole thing of an asymptote is the graph can never touch the asymptote. There, that's better. So there's our graph. The blue graph is the original function. The green graph is what 1 over that function becomes. Okay? Now it asks us to graph x plus 1 and its reciprocal. This reciprocal is represented by y equals 1 over f of x on the same set of axes. So, what does x plus 1 look like? You should use a ruler for this. Or something straight. X plus 1 is going to look like this. There it is right there. There's your x plus 1. Now, what would 1 over f of x be? Well, remember, the first thing I would do is set up where my asymptote is. The asymptote is going to be where there is an x-intercept. And then go ahead and draw there you go. There you go. There you go. And there you go. That's what it looks like. Okay? I'm going to flip back here for just a second because I'm going to see if it does say anything. It doesn't. So, unless it says it down here, and it doesn't, I'm going to make the point now. This point here and here, it doesn't change. When we graph f of x and 1 over f of x, it doesn't change. So points that don't change after you do a transformation are called invariant points. And in this situation, for this graph, these invariant points are really important. Because after we plot the asymptote, the invariant points help us as kind of like anchors in order to draw the rest of the graph. Next example. Now we're going to look at what would x squared plus 1 be, and what would 1 over that look like. So x squared plus 1 would be starting right here, and then up to here. Oops, already messed it up. See if I can do better. No, here. There we go. So this is what the function looks like. We're going to draw it in now. There it is. There it is. There's f of x. Now, the million-dollar question is, well, what would it 1 over f of x be? It is hard to see. There's no asymptotes because there's no zeros. But, so the next thing you would do is you'd say, okay, well, is there a point where y equals 1? And sure there is. It's right here, actually. It's where the vertex of the parabola would be. On the original function, if you go anywhere to the left or to the right of that, the graph shoots up, and it shoots up quick. So the same thing's going to be happening here, but instead of shooting up, it's going to shoot down. And 1 over a really, 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 really big number, still bigger than 0. So we don't have much room to play with here. But if we show that the function kind of goes like that, then we've won. Okay, so that's what it looks like. Okay, so that's what 1 over f of x looks like. We should probably label this too. So I'm going to say that this is f of x, and this is 1 over f of x. Whenever you have more than one graph, it is pretty standard procedure to graph or to label those two graphs to make it clear which is which. Okay? All right. Another example. Here we don't have like a function that we're familiar with, but still asks us to go ahead and draw the reciprocal of this would be. So our steps are the same. Are there any intercepts? And there's 1. So we're going to go ahead, we're going to try and draw on that asymptote. So there it is. And then we're going to kind of figure out where is there any values of 1 or -1, because then those could be our invariant points. Well, there would be like right here. Now, if that gets smaller, then it's going to get bigger. Here it gets bigger, so it's going to get smaller. But it's only going to go up to, it's going to go, while the graph gets bigger, it only gets bigger to 4 and then it stops. So really to the right here, it's going to go down, it's going to get smaller. It's going to get gradually smaller. But then it's going to stop and it's going to level off. I didn't do a very good job of showing that. So let me do that. Now the only thing is that there's no arrow on this, so actually I shouldn't be putting an arrow either. It stops at 10, it doesn't have an arrow, so my graph should stop at 10 as well. That's something you always have to kind of ask yourself is, does it go forever? Now you might say, well, why is there an arrow right here? Well, there's an arrow right there because it is going to keep on going forever and ever and ever up and forever and ever and ever left, but it's never going to touch the asymptote. Now, on the left side of the asymptote, we have our invariant point here. That's going to help us do this. And then it goes to about 2, which means we're going to go to about half. And again, it kind of stops at -10. So we need to stop at -10 as well. So what we've drawn in blue is what the reciprocal function of this function will look like. And again, it's the asymptotes that help give the reciprocal functions the nice curvy nature that they have. Okay? We have one more example here. The graph of a reciprocal function of the form 1 over ax plus b is shown. So we're given the reciprocal. We're asked to find out what the original function was and to sketch it. And I guess it depends on whether you can figure that out first. Well, first of all, the important thing here is, like, we'll know that there's a 0 at -4. So we know there's a 0 at -4. Let's make this our -10 to 10, -10 to 10 graph. So there is a 0 at -4. And it tells us the y-intercept is 1/8. So if we take the reciprocal of that, we're going to get the original one. What's 1 over 1/8? Well, how many 1/8 go into 1? The answer, 8. So 8 is going to be the original x-intercept. So the graph is our first step. There it is. There's our graph. That part's done. Now what's the equation? Remember, our equation has to be in the form ax plus b. Well, a is your slope. We'll get back to it. B is your y-intercept. B is 8. We can see that from the graph. Now the question is, what's the slope? Also from the graph, you can see that the slope is 2. So our equation, the original function, is going to be y equals 2x plus 8. And what we saw up here in red is the reciprocal of that equation there. So that's the original function right there. Y equals 2x plus 8. For homework, you're going to be doing numbers 1 to 22 on pages 403 to 409. Make sure to get as much practice as you can.